Okay, good afternoon, ladies and gentlemen. Welcome to the lectures of the elementary principles of chemical processes. Today, let's go to the chapter 2, Introduction to Engineering Calculations. First of all, let's again think of the process. I hope you still remember the mass production of penicillin can be described in these processes. Okay, you have raw material in and the product out. So through these processes, you can have mass production penicillin products from raw materials, and you can go to process A, process B, process C, process D, etc. Okay. And another example is polyethylene production. Polyethylene is from the raw material ethylene. So ethylene is a kind of C2H4, which is in gas phase. Okay, so and then you want to have polyethylene production. Okay, polyethylene is kind of a polymer which is in solid form. So once you have this polyethylene, you can make many products like pipes, film, PE film, and rubbish bins. Okay, so this is raw material. These products, of course, after products, you can make final products for different applications. But however, from the ethylene to polyethylene, you need to go through these processes. For example, like process A, process B, process D, process D, E, C, and process D. And finally, you got products. Okay, so you also have processes. So if we think of these two production, penicillin production and polyethylene production, is any similarity compared to this? If you compare these two processes, what kind of processes looks similar? Okay, they all have reactor. Okay, they all have reactor, and they all have filters. They all have dryers. And then so in the lectures of the chemical engineering, you will learn how to design the reactor, how to design the filter, how to design the dryer for different applications like penicillin production application or polyethylene production applications, right? So what you need to learn is process, many processes, and you combine these processes together. So what's processes? It can be applied, it can be a chemical manufacturing processes. It can be a genetic engineering laboratories. It can be pollution control facilities. So these are all can be described as processes. Okay. So the definition of processes is the systems described involve process designed to transform raw material into desired products. For example, raw materials go into process or processes, and you become products. So when you have process or processes, there are many conditions you need to think and you need to design, like what's the size of the process, what's the amount you need to fit into the process, what's the flow rate, input and output, what is the chemical composition in the process, how do you set the temperature, how do you control the pressure, etc. So the basic fundamental of chemical engineering process is that you have raw materials and you need to do the pretreatment for the raw materials, and then you will have chemical process or physical treatment. And then after that, you need to do the purification, and then you make this as a products. So however, you might have byproducts, or you might need to recycle. But the process will also basically involve chemical reaction and physical separation, physical processes, and pretreatment and the purifications. So the objects of this text is that we want to systematically approach the solutions of the problems. And during these processes, we might have problems, or we need to design, or need to have some solutions. So part 1 is the basic techniques, which is involved in chapter 2 and chapter 3. So we might need to expressing the values of the system variables, like pressure, like temperature, like what's the size, and then we're setting up and solving the equations. This is part 1, which is basic techniques you need to learn as a chemical engineer. And part 2 is the laws of the conservation of a mass. So this will be in chapter 4 to chapter 6 in your textbook. And part 3 will be the laws of the conservation of energy. I don't know we have time to introduce you about this topic or not, but I will try my best to let you know about the laws of the conservation of energy during this semester. Okay, so first let's go to the section 2.1, units and the dimensions. First of all, there's a value you need to know. What's the definition of value and the units? So all the measure or quantities has a numerical value. This is numerical value and unit. So here I'll give you an example, like 2 meter. Okay, 2 meter is a measure or counted quantity, right? 2 meter. 2 is value. Meter is unit. Okay? So this is 1/3 second. So 1/3 second is that 1/3 is a value, right? And second is a unit. Okay, so this is the meaning of the value and unit. How about dimension in this section? Dimension, the definition of dimension is that a dimension is a property that can be measured or calculated by multiplying or dividing other dimensions. Sounds difficult, but actually it's not. So let me use this flow chart to let you have a better understanding. Dimension is that you can divide into 2 categories. One is you can measure it. One is you can measure or you can count or calculate it. For example, once you can measure is mass, you can measure, right? 1 kilogram, 1 grams. Time, 1 second, 1 hour, right? Length, 1 centimeter, 1 meter. You can measure. This is dimension. And also, dimension can be calculated, like mass per cubic length. This is what? This is density, right? Okay? And length divided by time, which is length divided by time. This is speed. Okay? This also can be regarded as a dimension. This can be regarded as a dimension. Density can be regarded as a dimension, right? Speed can be regarded as a dimension. Okay, so definition of dimension is this. How about second and hour? Are they the same unit or same dimension? Okay, this is dimension of time, right? Second and hour is dimension of time, but it's different unit, right? Because second is 1 unit, hour is 1 unit. So they are different units, but they are the same dimension. Okay? So the dimension can involve many different units. In this case, it can be second, hour, day, right? Years, right? Okay, so dimension is time, but unit can be second, hour, day, years, for example. So you can regard unit as an algebraic variable. Algebraic variable is that, for example, 5 centimeter minus minus 3 centimeter is equal to 2 centimeter, right? So it can be regarded as a 5x minus 3x equal to 2x. Okay, so unit algebra. So let's think of the how about 5 seconds minus divided minus 3 seconds. 5x minus 3 1. That's if you regard x as a centimeter, y as a second, it doesn't work, right? It doesn't work. So it can, but however, the different unit cannot be plus or minus, but different value can be multiplied, for example, or divided, right? 5 centimeter divided by 3 seconds is become a different dimension, which is velocity dimension. Okay, so let's summarize the section 2.1, units and dimensions. There are 3 key words you need to remember. The first one is volume, like 3 meter. 3 is a volume, right? Meter is a unit. Okay, and if you have a lot of units together, it can be regarded as a dimension, like time dimension can be second, hour, right? Year, time. Okay, this is time dimension. Right, the second 2.2, conversion of units. So what's the conversion factor? For example, if we have 36 milligrams and I want you to convert it to grams, you might say, well, how many grams is this 36 milligram? You can easily answer me, right? It's 0.36 grams. But if I want you to write it as a kind of equation, can you write it for me? So you need a technique to learn this, right? How about 5 nanometer? I want you to convert 5 nanometer to meter. You might say, well, Professor, 5 nanometer is 5 times 10 to minus 9 meters. I know you know, but please write it down as an equation to show me you know it. So this is what we call conversion factor and dimensional equation. Okay, so you need a conversion factor. Okay, let me show you how to do it. So 36 milligram times what equal to 0.036 gram. So I'm sure you understand that 36 milligram times 1 gram divided by 1000 milligram. So 1 gram equal to 1000 milligram, right? So this is 1 anyway, equal to what? 0.036 grams. So you omit milligrams. In the end, it becomes grams. So this is what we call conversion factor. Okay? Or if you don't like this, you say, well, Professor, 1 milligram equal to 0.001 grams. It also works. So this also is the conversion factor. It just expressed in different way only. Okay, so remember this is conversion factor. How about 5 nanometers equal to how many meters? So I'm sure you understand that 1 nanometer equal to 10 to minus 9 meter. So if you have a conversion factor like this, you remove nanometer here, and in the end you get meter. And also you understand 5 nanometer equal to 50 angstroms. So the next term you need to know is called dimensional equation. As we know that 36 milligrams times 1 gram divided by 1000 milligrams equal to 0.036 gram. So this is conversion factor, right? So, and this is what we call dimensional equation. What is dimensional equation? Is that you try to convert the units from one to another. So use a vertical line instead of the multiplication symbols. Multiplication symbols is this, use vertical line here. So this is what we call, this is conversion factor, right? And this is what we call dimensional equation. So let's do it step by step. Step 1 is write a given quantities and its unit on the left first, and then write down the units of the conversion factor. So you need to, step 2 is you need to put the unit of conversion factor that cancel the old units and replace them with the desired one, like replace nanometer to become meter, right? And step 3 is fill in the values of the conversion factors, like 1 meter equal to 1 nanometer equal to 10 to minus 9 meters, right? This is value. Okay, and carry out the indicated arithmetic to find the desired value. Okay, you do a simple calculation, you find the desired value. Right, here's the example. Okay, I want you to do 1 centimeter divided by second power 2. And I want you to convert this unit to kilograms divided by year power 2. How can you do that? So let's do it step by step. Okay, so first of all, you put 1 centimeter here and second power 2 here. So you have a denominator and a numerator. Okay, so first of all, you want to convert centimeter to become kilometer. So centimeter, you have to omit a centimeter. Let's do it step by step. Okay, centimeter to become meter. Okay, you have 1 and it's 100, right? 1 meter equal to 100 centimeter. And this is, meter is not the final answer because you want to convert it to the kilometer. So here you will be meter and here will be kilometer. Okay, and 1 kilometer equal to 1000 meter. So as you omit this centimeter, meter, in the end you will get kilometer, which is the answer. Okay, so you completely convert the centimeter to a kilometer. And now let's go to the second. So 1 second power 2 equal to 60 power 2 equal to 1 minute, right? You understand this. And so you omit the second and now you have minutes. So you have to omit minutes to become hour. You have to omit hour to become days. You have to omit days to become years. Okay, so now you have second, convert second to become year, convert centimeter to become kilometer. Okay, so in the end you just add up, you just times 1 times 1 times 1 times 60 power 2, 60 power 2, 24 power 2, 365 power 2. And in the denominator you have 1000, 100, 1000, 1111. Okay, so in the end you get an answer here. Okay, so the section 2.2 conversion of a unit, there are two key words. The first one is conversion factor. Okay, the second one is dimensional equation. So you need to learn this systematically so you know how to convert the units. Okay, the section 2.3 system of units. Okay, the first one, let's start to learn components of the system of the units. So components of a system of units is, there are three components. The first component is base units. The second component is multiple units. The third component is derived units. Derived units. Okay, let's go through this one by one. What is base unit? The base unit is mass, length, time, electrical current, temperature, luminous intensity, and finally amount of the substance, which is we call mole, right? And this luminous intensity, light intensities. Okay, there are only 7 base units. There is no 8. There is no number 8. Okay, only 7 base units. Please remember, there is no number 8. How about multiple units? Multiple, I'm sure you already know this. Second can become minute, hour, year. So these are multiple units. They belong to the same dimension, right? Okay, number 3, derived unit. Oh, you already know what's derived unit, which is compound units, mix of the time and about the 7 base units, right? So this is base unit, base unit, base unit. So this is a mix of the 7 base units. Kilogram times meter divided by second square. So this is called compound unit. I'm sure you know this. This is the force, right? Force. However, you don't need. You can write down like this, or also you can write down like Newton. And this symbol represent Newton, right? So this force equal to mass times acceleration. So mass times acceleration equal to force. We use N to instead. Okay. So the system of the unit is that there are 3 systems of units. Again, first one is SI system. Second one is CGS system. Third one is American engineering system. So as we know that there are only 7 base units. For the SI base units, meter is for length. Okay, meter is for length. Meter here. And kilograms is for mass. Kilograms. And second is for time. Ampere is for electrical current. Kelvin is for temperature. And candela is for luminous intensity. And moles is for amount of the substance. So this is the base SI base units. So let me give you a question. How about the voltage? Can you give me the unit of this volt using these 7 base units? So as we know, volt is equal to current, electrical current times resistance. So it's amp times ohm. Amp is here, right? But ohm, this is not base unit. So you cannot write down amp times ohm is the unit of the volt. No. So what's the definition of the volt? So 1 volt is defined as the differences in electrical potential between 2 points of a conducting wires when an electrical current of the 1 amp dissipates 1 watt of the power between those points. You might get confused, but let me write it down for you. Volt is the potential energy. This is the unit of energy divided by charge. The charge divided unit is called coulomb. Okay, you know energy is Newton force times meter, right? Okay, so you understand how about the coulombs. Coulombs is amp times what? Second. Okay, so this is unit of the energy. This is the charge. So you know the definition of volt is potential energy divided by charge. So as a result, you can write down the unit of the volt is kilogram times meter square divided by amp times cubic second. Okay, so this is expression of the unit of the volt. How about so let's take a look at the CGS base unit. As we know, SI unit is like this: meter, kilogram, moles, second, Kelvin, amp, CD, candela. The only difference between the SI unit and the CGS unit is length and the mass. The length changed from meter to centimeter. The mass changed from kilogram to gram. That's it. So what you need to remember is very similar. The SI unit and CGS unit are very similar. Only two different. Only mass and the length are different. Different units only. Okay. So the other thing is the multiplying units preference. You might hear that kilograms, mega, giga, tera, penta. This is when you use computer, you have memory stick like this. Okay, memory stick like this, your gigabyte and terabyte, right? This is the capacity of the memory stick. So you understand the tera is 10 to 12. The size is 10 to 12. Giga is 10 to 9. Penta will be 10 to 15. Okay, and you already know what is kilo, mega, right? How about a centimeter? A centi, mini, micro, nano, pico, femto. So you know nanometer is 10 to minus 9, right? Centi is 10 to minus second. How about femto? Femto is 10 to minus 15. As you know that the LASIK laser for your short-sighted eyes, right? Femto, this is female is femto. Femto is the 10 to minus 15 seconds laser. So it's very short, very quick laser. Okay, so femto is 10 to minus 15. Tera is 10 to 12. So this is derived units: area, okay, volume, density, force, pressure, energy, power. Energy, you know that. Then you know the power. Power is energy divided by time. Okay. Frequency of charge. Frequency and electrical charge. We just learned this. Electrical charge, right? Q is equal to coulomb. Okay, it's amp times second. Okay. So electrical voltage. We just learned this, right? Volt. Okay, resistance. Okay. So if I want to ask you what's the please express resistance using the 7 base unit. Can you give me this answer? I'm sure you can. Right. The system unit of the last one is American Engineering Systems. For the length, we call it feet. For the mass, we call it pound. For the time, it's second. Right, the same as SI. So how to convert a unit from feet to centimeter? So we need to check from the table, and you can get this table from our textbook, or you can get this table feet to centimeter from the Paris Chemical Engineering Handbook. This was the Bible in my age. Okay, this is very chemical engineering's Bible, engineer's Bible. Okay, there are many informations, very important informations. However, it's not necessary for you to check how to convert feet to centimeter using these two using the book, the textbook or chemical engineering handbooks. You can easily to get through from this to get the answer from the internet, right? Now. But however, now this information you can get it easily, but however, I want you to, for example, length, value, weight, pressure, flow rate, and output, the energy and watts. There are many tables, or you can have a kind of calculator to work for you like this. But I want you to remember only 3 things only. This is useful, is that 1 inch is equal to 2.54 centimeter. Please remember this. In your exam, I won't give you this information. Okay, you need to remember this. The second one is 1 kilogram equal to 2.2 pound. Okay, or 1 pound equal to 0.4536 kilogram. Okay, you need to remember this. And third one is temperature. So 1 Fahrenheit equal to 1.8 Celsius plus 32. You know, this is also useful because we use centimeter, kilogram, and Celsius in Taiwan. But if you go to United States, you will use inch. You will use inch, right? You will use pound. You will use Fahrenheit. So I want you to remember these 3. When you have your midterm exam or final exam, I won't give you this information. So please remember this. Okay? So here is an example of 23 pound mass times feet divided by minute square is equivalent to kilograms centimeter per second square. How can you do that? Right, again, you need to write down the dimensional equation, right? And you need to write down, and step 2 is you need to write down the unit values, unit and value, right? Okay, unit and value. Dimensional equation, step 1, unit and value. So let's do it. A 33 pound mass, so you have a 33 pound mass times feet here, and you have minute square, right? So first of all, you you do the pound mass first. The pound mass equal, you need to change it to kilogram. As I just told you, you need to remember this. 1 pound mass equal to 0.45. You can just remember what 0.454. Okay, 0.454 kilogram. You don't need to remember the rest of it, the rest of the numbers. Okay, so you convert pound mass to become kilogram. Okay, and now you need to convert the feet to the centimeter. So 1 feet is equal to 30.48 centimeter. Okay, feet, and then feet to centimeter. And now you need to convert the minute to become second. So minute and second here. So 1 minute is equal to 60 seconds. So now you have kilogram, right? Centimeter and seconds square. All you need is to add up these numbers. Multiply these numbers, 33 times 0.454 times 30. And 1 times 1 times 60 square. So this is the answer. Okay? No, so why this is so important? Because this is one of example is the NASA metric confusion caused the Mars orbital loss. So this orbital corrupt in the Mars because one engineering team used metric units while another team used English units. So these 2 teams didn't get together. So for key spacecraft operation, so they lose these orbiters because 2 teams using different units. So it's very important to learn the conversion of the units, right? Otherwise, you lose a lot of money. Lose 125 million orbiter. Okay, so you need to learn this. So conclusion of the 2.3 is system of units. Important thing is that you need to learn there are only 7 base units. Okay, there's no number 8. Okay, and you need to know how to convert between the system of units like CGS, SI, and American Engineering System. Okay, so you need to basically remember the weight and the temperature and the weight and the length and the temperature. Okay, right, so that's it. Next section is section 2.4, force and weight. As we all know that force is equal to the mass times acceleration, right? This is Newton's second law of the motion, right? So, however, if we want to understand the units and dimensions, SI unit, CGS unit, and American Engineering System units. So, SI unit, force will be 1 kilogram times meter per second square. That will be also called newtons, right? Newtons. How about CGS? CGS will be 1 dyne. American system will be 1 pound force. You might say, wow, professor, something wrong with this. I learned 1 pound mass, but I don't know why it's 1 pound force. So 1 pound force is a unit mass and acceleration of the gravity at the sea levels and 45 latitude. Okay, so 1 pound force will be equal to 32.174 pound mass times feet divided by second square. So as we know that 1 pound force will be 32.174 feet per second square. Okay, this is pound mass times 1 pound time mass times this. Okay. Right, so you need to understand the pound force and pound mass. So the weight will be first of all, if you want to understand the weight, we need to know the gravitational acceleration. So value of g at the sea level and the 45 latitude is given below each section of the units. So the gravity will be equal to 9.8 meter per square second, right? And you understand now this is SI system. CGS system will be 980.66 centimeter per square second square. And for American Engineering System, gravity will be 32.174 feet per second square. So we all know that weight is the mass times the fuel free fall acceleration. So this is the example. So in a SI system, if we want to know what is the force, if we have a 4 kilograms and the acceleration is 9 meter per square meter, second square. That will be force equal to mass times acceleration. Then if you use dimensional equation, the kilogram here is 4 and the mass second square will be 9.00. And we understand this is kilogram or meter or second square, that will be Newton. That's Newton. So as a result, we understand this is 36.0 Newton. However, if we use the same value but different unit, for the 4 pound mass, acceleration is 9.00 feet per square second. And I want you to convert to the pound force. If you use the dimensional equation, you'll realize the pound mass, you have to convert pound mass to the pound force. So here we understand 9 here, okay, the pound force, pound mass per feet times feet per second square will be equal to 32.174 pound mass times feet per second square will be equal to 1 pound force. So as you remove this, you will get pound force. So the pound force will be 1.12 pound force. So this Newton is the pound force. So the important thing is that you need to know American engineering system. There's a pound force differences between pound force and pound mass. Okay. So let me make a conclusion of this 2.4 pound force and weight, and you need to know gravitational acceleration. In old time, you have British unit, you have American unit. So this is the somewhat information for you to know. And you know the meter, second, and gram are the best three best units, right? So this is the definition of the 1 meter, 1 second, and 1 kilogram, just for your information. So let me summarize this section from 2.1 to 2.4. First of all, you need to know what is process and what are the processes. And then you need to know volume, unit, and dimension. And the system of the unit, there are 3 systems of the unit. First one is SI system, second one is CGS system, and third one is American engineering system. And the unit will be base unit, multiple unit, and the derived unit. There are only 7 SI base unit, okay? Or 7 base unit only, no number 8. So the conversion between units, you use conversion factor and the dimension equation. And finally is the force. You need to know what is the force and what is the weight, and especially pound force and pound mass.